Rational and irrational numbers, so it says convert 28 over 11 to a decimal. Circle the correct alternatives in the following statement. So go ahead in your calculator if you have it handy, just put 28 divided by 11, and then label that as repeating or non-repeating pattern, terminates or does not terminate. So what do you see? Yeah, so it's repeating, right? It's 5, 4, 5, 4. Okay, and then it's also does not terminate because it's repeating. Okay, now try 28 over 8 in your calculator. It says circle the correct alternatives in the following statement. Decimal is repeating or non-repeating. Non-repeating, right? Okay, and then it terminates. So that means it stops. Because it is, did you guys get 3.5? Okay, so 3.5, it doesn't repeat and it terminates. And we talked about this when we talked about rational versus irrational. And then root 2, okay, sorry this thing's in there, but root 2, not repeating, correct? And it does not terminate. So you can see it keeps going. That is your definition of an irrational number. Non-repeating, non-terminating decimal or number. Can't be put in fraction form. Okay, anything that can be put into a fraction is not going to be irrational. Okay, so that's why radicals, and we're doing radicals this unit, that's why radicals often are the most common irrational number. What's another very common irrational number? Pi, right? Pi goes on forever. Very good. Any others? Okay. For those of you guys who have the TI-83s, there's an E on there, it's called. Use that in logarithms. What's that? Yes, that's from, yep. You got that from Moore, I think, Mr. Moore? Yeah, that's the one. Okay, good job. All right, so moving forward here. So terminology, repeating decimals, decimals which have reoccurring pattern of digits. Non-repeating decimals which have no recurring pattern of digits. Terminating, it's a finite number, it stops. Non-terminating, it keeps on going forever. Okay, so going through this, state whether the decimal equivalent of each number is repeating or non-repeating. Also state terminating, non-terminating. You can just kind of initial this if you want. Just put R and then T and then NR, NT, whichever you want to do. You don't have to write the whole thing out if you don't want to. So for example, everybody in here knows 1/8. That's going to be non-repeating. So NR, and then it terminates. It stops. Okay, 1/8 half of 1/4, so it's like 0.125. 2 over 11, repeating. Okay, and non-terminating. How about 9 over 7? What do we see? Did you get it? Okay. I have non-terminating. Is it repeating or not? Let me see here. Must be a mistake on my notes then. That's good. Okay, so you've got non-repeating, which makes sense because, let's see here. I want to double check here for the video here. Okay, so on C, it is going to be repeating and non-terminating. You'll see on your calculator that it does go, and then it goes like this, and then you can't see the next number, but it does continue. Some calculators are around that spot, but it does go again, and then it is non-terminating. So it's repeating, non-terminating. Okay, 0.94, well that bar means repeating, so we know that. And then means non-terminating, so it's repeating forever there. Root 8 is neither non-repeating, non-terminating. And 0.16 is non-repeating, and it terminates. It's 0.04. Okay, or is it 0.4, I think. All right, questions on those? Just that one hiccup there on C. Everything else good? All right. Okay, so rational versus irrational numbers. So again, this is from last year. Decimal numbers which repeat or terminate can be converted into fractions. Those are called rational numbers. Decimals that are both non-repeating and non-terminating cannot be put into fractions. They're called irrational numbers. So identify each of the following as rational or irrational. Give a reason for each case. So right here, is this repeating? Is this terminating? Yeah, so this is a rational number, right? It stops and it's not repeating. Root 5 is an irrational number. You put in your calculator. So in this one is it terminates and non-repeating. This one doesn't terminate and non-repeating. That's why. Okay, C is repeating and does not terminate. So what would that be? Yeah, it's rational. Has to be both ends to be irrational. Square root of 81, that's just 9, so it's going to be -9s. This one's going to be it terminates and non-repeating. Square root of 4.41. So we do that, what's that going to be? What's that? 2.1, so it terminates. And it's non-repeating. So this would be rational. So they're doing this to make sure, like, just because it says a radical doesn't mean that it's automatically irrational. Okay, you have to check and see, because square root of 81 is 9. That's a whole number. That's definitely a rational number. Okay, how about F? It's got a pattern, but is it repeating? Yeah, it's not repeating and it's not terminating. So this is definitely going to be irrational. Okay, go ahead and give you a second here, and we'll go ahead and order those 5 on the number line about where you'd put them in terms of on the number line, so you can use your calculator to approximate, or you probably know this is 3.14, so you can put that around 3.14. Okay, so where am I going to put A?
Just like in between 3 and 4, but not too close to 5, like past the middle.
Okay, right about there. So we'll put that right there for A. Okay, B, where's B going to be, Rich?
A little bit past 3.
Okay. Pen's being a little weird today. Okay, B is right there. C. Luke?
It's like
Close to the 9. Okay. Okay, good. Denise, where's D at?
like right before the 8.
Right before the 8.
Like a little bit.
Okay. Gosh, I don't know why it keeps doing that. Okay, and then that's D and E. Okay, where's E at? Right after the 0. Okay. Okay, so that's roughly where they're at. Good, just kind of give you some number sense of radicals. The good thing to use for radicals is to figure out, like, for example, 80 is close to 81, and then we know the square root of 81 is what? 9. So that's why 80 is really close to 9, but not quite. Okay, so you kind of use your perfect squares as your landmarks, if you will, okay? All right, so here's just how you can do it on your calculator. So using graph calculator to convert repeating decimals. So you can see this, what they did here. In the calculator, you can try this. Just put 0.36 a bunch, and then hit math fraction, and it should convert it to what it is as a fraction. So see if you can get that to work on your calculator. What's that? Oh, so yeah, it's for the TI-83s. So I don't think you can do it for those ones. So it's for these guys. If you have these guys, which you're going to need this eventually, okay, that's what we're talking about. It won't work on your phones. It won't work on the scientific calculators. It'll work on this one, okay? They're about... All right, keep it on moving here. Last page already. Whoops. So converting or repeating decimals to fractions algebraically. So that's how you do it with the calculator. There actually is a kind of, I actually think it's kind of neat how you can do it with using math instead of the calculator, which I guess it probably makes me a nerd, but that's fine. Okay, so step 1, let x be the original number. Identify the digits which repeat. Multiply both sides in step 1 by a power of 10, which moves the repeating part to the left. You'll see what I mean in a second. So these are just the steps to follow. Okay, if necessary, multiply both sides in step 1 by a power of 10, which moves the repeating part immediately to the right of the decimal point. Subtract the equation in step 4 from 3. So let's just look what they're talking about here. All right, students using the above to convert the procedure of 2.051 to a fraction following this procedure. So he said let x be 2.051. The repeating digits are what? It's over the 51. To move 51 to the left, the decimal, he needs to multiply it by what? We need to move these two, so the 1, 2, 3 spots. Because we want it to be on the other side of the decimal. Does that make sense? So the last digit of what's repeating, you want to move to the other side of the decimal. So we're moving it 1, 2, 3. So 3 means 3 zeros. That's why they used 1,000. So they multiplied this by 1,000 to both sides. Is everybody okay with that? So it's 2051.51. Okay, to move the 51 to the immediate right of the decimal point, multiply both sides by 10. Okay, so this one here, we did by 10. So we have 10x now. Let's see here. Okay. So remember we have up here, x equals 2.051, so we're going to multiply it by 10, which makes it 20.51. So what they did with it, we just cut out this little 0 here. So it's right next to the decimal. So you have one with it just to the left, one with it just to the right. Just to the left, just to the right. Okay, so now we're going to subtract them. Okay, what we do is we do this just like straight down. We line these up, and I'm minusing this, and I'm minusing this. The reason we do this is because if I minus, look what goes away. Those are the same thing. So they just subtract off. So we're cutting off the repeating decimal. That's what we're doing. Does everybody understand that? Okay, we'll do a couple of examples here, but so this is gone. Okay, so then we're going, okay, 1 minus 0, 1, 5 minus 2, 3. That. See, it's a whole number. It's nice. There's no more repeating things. 1,000 minus 10 is 990. And then we just divide. And so you get x equals 2,031 over 990. This reduces as a fraction to 677 over 330. Okay, let me pause there for a second. Okay, so what we did was we manipulated what they gave us in two different ways. Okay, we did the first way where we moved the stuff over so that the repeating part was hanging on the left side. Then we made sure it was really close just to the right side. Then what we did is we subtracted these, which you can do that because it's a system of equations to solve for x. Because what we're doing is x represents the fraction of that number. So what I'm saying is, right now in your calculator, guys, what is 677 divided by 330? Should be 2.051 repeating, right? So by solving it, we just found out the fraction. So we just turned this into a fraction. Okay? So again, we know this equals this. That was the purpose. Found the fraction that creates this repeating decimal. Okay? Let's do another one. I see a lot of confused faces. That's okay. The only problem is I don't hear a lot of specific questions. So let's try this one. Okay? So by following the steps, What do we want to do first? Good. First thing, let x equal 0.36 repeating. Okay. What do you want to do next? By 100, because we want to move the whole thing on the other side. There's two numbers. So I need two zeros. That's 100. Why did we do 1,000 last time? Because there's a what? That 0 was in the way. Okay? So we're doing this by 100. So we're going to go 100x equals 36.36 repeating. So we don't have to do the other one because it's given to us where there's no gap. You see what I'm saying? There's no 0 there. So we just go right to this. See, they're lined up. The whole purpose of doing this, please understand, is we're trying to get rid of the repeating piece. Everybody understand that? Okay. Yeah? Okay. So we minus, that's gone. 36, that's just 36. 100 minus x is 99. 99x, I mean. Divide by 99. Gosh, this pen's being weird. Divide by 99. So that is the fraction. Oh, that reduces. That's going to be 12 over 33. What's that?
How did you get 99?
100 minus 1.
What?
100 minus 1.
Why is the x 1?
It's a 1x. There's nothing in front of it. It's always a 1x if it's by itself.
Yeah, right.
Yeah? You good?
Yeah, I'm good.
All right. So this would be our answer. 12 over 33. Which, oh yeah, go again, can't I? 4 over 11. Which we already knew that, didn't we? 4 over 11. One more stop, sorry. Good, good, good. Okay, try B on your own. Let's see if you can do B on your own. Walk yourself through it. Okay, I'll give you a couple minutes here. Yeah, okay. So we need to get this repeating sign on the left side of the decimal and the right side of the decimal. So to get to the left side, I need to move it 2 spots. 2 spots is 100. X equals 395.5 repeating. Okay. Then I also need to get it right here. I want the repeating spot right there where the 9 is, so I need to move it 1 spot. 1 spot represents 10x. Then it's going to be just 39.5 repeating. Again, if you're lining your stuff up and you have, like, for example, if you didn't move it, if you just put x, your problem is you have a 9 here now. So I can't get rid of those. That's why we have to do that. Yeah, Maddie?
So then you don't multiply 10 by the 395.5 repeating, you multiply by 3.95 repeating?
Right, you have to come back, excuse me, very good point. This is what represents our x. That's what we're multiplying by. Sorry, I skipped that step. Very good point. Like right here, let x equal 0.36 repeating. So this we're multiplying by 100. This we're multiplying by 10. Okay? Good question.
Why don't you just start with 10?
You could have done 10 first. It doesn't really matter. But the reason they make you move it the bigger number first, because you want to subtract the bigger number by the smaller number. So that's why. Just because we'd rather not go 10 minus 100, right? Just gives you a negative, but you still can. Okay, it just won't be wrong. Okay, good question. Yeah, does the order matter? The order doesn't really matter. You just get a negative. Okay, so you have to divide. All right, so here we go. We're minusing those. 100 minus 10 is 90. These is gone. That's gone. And then carry, so 6, 8, 5, 356 divided by 90. And so that reduces to 178 over 45. So again, if you put this into your calculator, that represents this value. Okay? I see the wheels turning. That's good. I'm getting you to think today. It's not super easy. All right? Okay, so we'll stop this one here.